Hi, everyone, and welcome to our third meshIQ Tech Talk, Scale Your Integration Mesh Observability with Kubernetes. So just to let you guys know, this Tech Talk is a third in a series of Tech Talks that meshIQ will be presenting bi-weekly. And our presenter today is Scott Corrigan, who is the VP of Technology Services at meshIQ. Scott, take it away.
Okay, Jennifer, thank you. And thank you all for joining us today at this Tech Talk. I want to start this presentation by making a clear differentiation between cloud computing and cloud native computing. So cloud computing is thought of as an evolutionary change in the way organizations provision and manage their computing resources. Cloud native, on the other hand, is something completely different. It's actually a fundamental change in our approach to development and deployment, and whether that happens in the cloud, on premises, or both. In fact, cloud native doesn't actually require the cloud at all. Now, one element that's essential to this concept of cloud native is containers. A container is a packaging of an application with all the libraries, configuration files, dependencies, and parameters that an application needs to operate. Now, I've taken a quote here from Jason Bloomberg. He's an IT industry analyst and a recognized expert in digital transformation. And Jason tells us that cloud native computing is in fact a paradigm shift. It changes everything we know about how to build and run modern applications. Well, in any industry, a paradigm shift is disruptive and it's challenging, but it happens because it also provides big benefits. Container adoption is actually a kind of a catalyst for innovation and efficiency. But as organizations scale their container workloads, they need tools to make management easy. Now, deploying and running a large number of containers in an organization requires a container orchestration platform. And that's why at the center of this cloud native movement is Kubernetes. Now, Kubernetes provides a comprehensive end-to-end control plane that empowers the organization to manage a portfolio of containerized IT resources. Now, Kubernetes has practically exploded onto the enterprise infrastructure scene with a number of open source and vendor-led flavors of Kubernetes in the market, like Amazon's EKS, Azure AKS, the Google Kubernetes engine, or Red Hat OpenShift. Now, Kubernetes today is the leading technology for managing containers, and it's at the heart of how enterprises are going to be running software and applications for years to come. The Cloud Native Computing Foundation, or CNCF, has been doing a survey each year since 2016 to study global trends in container adoption and the use of Kubernetes. In 2021, based on the data that they collected, they concluded that container adoption had started to go mainstream and that Kubernetes had started to become ubiquitous. 93% of the people who responded to this survey said they were planning to use containers in production. And 96% of the respondents said they were currently evaluating or using Kubernetes. The CNCF speculated that the reason for this is because more and more organizations are using managed services from cloud vendors, so they don't necessarily need to know the underlying container technology. Now, the CNCF just published the 2023 edition of their annual survey last month in February, and it shows that organizations are embracing cloud-native technologies at an accelerated rate. Organizations are reporting an increase in development of containerized applications, and the percentage of their application portfolio running in containers in production is increasing year over year. Now, the primary reason why there's an acceleration in container adoption, why this is changing so fast, despite its challenges, is because organizations are starting to see quantifiable benefits in running container technologies. And the benefits that are most frequently cited are things like increased developer speed and efficiency, greater agility, support for microservices, portability of containers, which enables organizations to run applications on multiple cloud platforms, cost savings on infrastructure, and finally, scalability. So cloud-native technologies have become the new normal. They enable organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. Well, since cloud-native computing has become the new normal, this means that if your company doesn't yet have applications running in containers, or if you're not currently involved in building or running container-based applications, it's very likely that you will be in the very near future. Now, if you're already running applications in a cloud-hosted compute platform, like virtual machines on Amazon's EC2 or Azure or GCP, it's very probable that many of those applications are going to be rebuilt to run on cloud-hosted container services platforms like Amazon's EKS, Azure AKS, Google GKE, or OpenShift. Now, alternatively, container-based cloud-native applications don't require the cloud at all. In fact, you can run containers in your own data center and take advantage of open source Kubernetes, or you can license one or more of the popular Kubernetes offerings from these cloud providers. And this logic applies not only to your application code, but also to your application integration infrastructure. So it's very likely that containerized versions of things like web servers, messaging, event processing, and streaming technologies are going to be used by your organization in the future, unless that's already happening. And this is where meshIQ comes into the picture. meshIQ is an observability platform for messaging, event processing, and streaming across hybrid cloud infrastructures. That's MESH as an acronym: messaging, event processing, and streaming across hybrid cloud. Now, it's designed for application and integration DevOps professionals, people who need a single pane of glass to manage and monitor the complex mesh landscape. The integration infrastructure, which is in essence the digital nervous system of your modern enterprise. It delivers complete management, control, and tracking across the mesh. Now, there are 4 core functional domains of the meshIQ solution. There's governance, which include things like configuration and message management, secure self-service for DevOps. Then there's intelligence. That involves real-time monitoring and proactive alerting. Action, which is about triggering automated actions based on events, and intelligent actions that are determined by machine learning. And finally, introspection. That's about performance analytics that are powered by historical data, and tracking and tracing of application message flows. Well, for meshIQ, Kubernetes is a deployment option for our customers who are seeking to leverage the benefits of using the world's most popular container orchestration platform to deploy our software. Now, benefits like speed and ease of deployment, a fast upgrade path for new releases, and an agile response to changes in scale of deployment. We started our journey in this world of Kubernetes in 2019 when we made our first cloud-native editions of our software available on the cloud marketplaces from AWS, Azure, and Red Hat OpenShift. Now today, meshIQ offers a variety of Kubernetes deployment options. You can deploy our solution on Kubernetes managed services from various cloud providers, or you can run it on open source Kubernetes, either on-premise or in your private cloud. Now, whether you deploy the meshIQ solution on a Kubernetes cluster, or on virtual machines hosted in your data center, or in a cloud-hosted compute platform, or in containers, the meshIQ platform in all those circumstances is built on the same reliable and scalable architecture. And that architecture can be described in 2 parts. There's a control plane and a data plane. The control plane is a scalable series of microservices that are used to build and manage and monitor the mesh. They're accessed via a web browser, and the control plane can be hosted by meshIQ or delivered on-premise or in a public or private cloud. Then there's the data plane. That's a telemetry layer that's connected to the messaging, event processing, and streaming endpoints, and it's used to relay metrics to the control plane. Now, the meshIQ platform is designed to suit the unique needs of various stakeholders within an organization, people with different areas of responsibility, but who all need the right tooling to make their jobs easier to perform. For example, people who work in shared services, they're responsible for the integration infrastructure. They're interested in middleware management and control. Application owners and application architects, they want to make sure that their applications are continuously running at peak operating capacity. They're looking to reduce outages, and they want to prevent performance problems. Application developers need self-service tooling in development and QA environments. And finally, application support staff, they're responsible for making sure that issues are fixed and, if possible, avoided. They want faster time to repair, and they want to be able to find the root cause of application issues quickly. So I want to talk to you about several use cases so that you can see how meshIQ can help you in real situations that you're confronted with on a daily basis. So let's start by looking at shared services, where administrators are responsible for the governance of several middleware technologies. Now that applications and middleware are deployed across hybrid cloud environments, their jobs have become more challenging. These administrators, they perform a lot of different tasks every day. They need to create and update and delete middleware objects like queues and topics. They need to investigate problems when things aren't working properly, propagate changes across environments, identify unused objects so that they can safely retire them from service, and take configuration backups. Now, administrators want the ability to do all of these things for all middleware, no matter where it's hosted, from a single connection in one web browser session. Well, in a meshIQ solution, the user interface is composed of a selection of dashboards. Now, each of these dashboards contain one or more views which contain displays of information that's related to objects selected from the mesh. The interface is customizable by the user. For example, you can create, modify, and delete the dashboards and the views. And you can change the search criteria and the display options of each view. You can also create user perspectives, so to organize a set of dashboards that are related to the same theme. This ability to customize the interface is designed to empower the user to create an environment that's specifically engineered to that user's job function and work methods. For example, the user can create custom schemas to define the layout of the information that's displayed in each view. And using a schema editor, the user can select the object attributes to be displayed, the order of the displayed columns, and also the sorting options. In addition to these custom schemas that control the set of attributes to be displayed, each view provides a set of filters that are based on search criteria that allows the user to control the list of objects to be displayed. So in this way, the interface is governed by search, with options that help you to find and focus on the objects that you need to work with. Now, this is a real benefit in terms of ease of use, because we've grown accustomed to getting access to information through search criteria without needing to know how that information is organized or where it's located. So even if you don't know that a given object is situated on a specific server or cluster or broker, you can easily find it through search criteria that you control. There's also a topology view that gives us ability to see relationships between resources within the mesh. We can use search criteria to customize this view and limit the display to named resources, like a subset of objects that are used in a specific business workflow. And it has display options that give us an animated view of messaging activity. Administrators working in shared services often need to investigate problems when things aren't working properly and update middleware objects in response to change requests. One of the techniques that's commonly used in troubleshooting problems involves comparing objects to ensure that they're properly defined. For example, An administrator may want to compare the attributes of topics selected from one or more clusters to examine their differences. Well, let's say that in this case, the administrator wants the attributes of these topics to contain uniform values. The administrator can open a property sheet for a selection of multiple topics and then make changes to specific attributes. In this example, we're looking at the properties of several selected topics from one or more Kafka clusters. Now you'll notice that some of these attributes are highlighted in blue. That's because those blue fields contain different values across the selected objects. Administrators often need to migrate or propagate definitions of middleware objects within an enterprise infrastructure. A good example of this use case is replicating a set of objects from a development environment to a testing environment, or from pre-production to production. With a meshIQ solution, rapid migration can be accomplished simply by selecting a set of objects and applying a copy and paste action. For example, to propagate a set of Kafka topics from one or more clusters to a target cluster, all we need to do is select one or more topics, select the copy button, select our destination path, and then press the paste button to complete the action. You know, application developers, they build business workflows that are highly dependent on messaging and event streaming. And while they're hard at work writing code for business applications, they often need a fast and easy way to test their message flows. And in addition to message management, developers want a self-service capability to create and manage their own middleware objects in development and testing environments. Developers don't always have time to submit change requests and wait for administrators to service those requests. And truthfully, administrators don't want to be perceived as the bottleneck in a continuous delivery process. Now, on the other hand, administrators are also responsible for the integrity and the reliability of the mesh. So in essence, we want to empower application developers to manage their own middleware objects and messages in development and testing environments, but we also want to manage that activity in a very, very controlled way. Well, the meshIQ solution simplifies object-level security. It provides role-based access control to users, teams, and groups, and it provides integration with LDAP for user authentication. Now, one of the most important aspects of secure self-service is high granularity. And that granularity is achieved by assigning role-based permissions to groups of users and then applying those permissions to groups of objects. As a result, application developers and also application support teams can safely be granted access to the same web-based tool that's used by administrators to view and manage the specific objects that are within their realm of responsibility. So administrators can set up dashboard templates that can be shared with DevOps teams with object filtering and context-sensitive menus that enable those teams to do their jobs. In this way, the actions that those users can perform and the objects that they can view or manage are dependent on user authorizations. The meshIQ solution has a compelling set of features for message management and search that's useful for application developers and other staff. The intuitive interface makes it easy to manage messages. Users can view and edit messages. They can load messages from files to topics and queues. They can copy and paste messages between queues or topics, and they can also search for messages. The solution provides powerful features for criteria-based search of messages. For example, search criteria based on character strings can be used to search for messages that contain business data, like orders or invoices. Search criteria can also be based on message metadata. DevOps users can make scheduled changes to objects so that the changes take place at a later time, such as during a maintenance window. The actions that can be scheduled include things like creating, deleting, and modifying objects, as well as start and stop actions. Message actions such as loading messages from a file or clearing a queue or a topic, they can also be scheduled. And authorized users can perform approval of scheduled actions, and they can also cancel them even before they happen. Also, scheduled changes can be coordinated with change requests from third-party software like ServiceNow. The meshIQ solution keeps a full audit trail of all configuration changes that are made to every object, so administrators can consult the event details for any change to a selected object and get a complete set of information about every change. What changes were made to an object, when the changes were made, and by whom. And at any point in time, administrators can review these configuration changes and optionally roll back selected changes. There's also a full audit trail of all configuration changes made to every object by any user. The solution provides an audit report that shows all user actions and whether those actions were granted or denied. Administrators can filter the audit report by user, object type, object name, type of access, and time and date ranges. In addition to the self-service approach for provisioning application resources, many organizations are increasingly adopting what's known as an infrastructure as code approach, so that the tasks of creating and maintaining the application infrastructure can be done with less human involvement. Now, infrastructure automation is usually accomplished by using tools like Ansible to write playbooks which contain descriptions of the desired state of systems. But organizations with applications that run on multiple middleware technologies sometimes find it challenging to write automation playbooks for managing the full application stack. So what playbook authors really want is an API interface that's simple, consistent, and reliable across all middleware and all platforms, from on-premise to multi-cloud. Well, meshIQ offers a REST API that's simple and consistent across all middleware. It can be used in automation playbooks to provision and maintain middleware resources. Now, this REST API enables administrators, as well as other users, to execute commands to perform the same functions that are provided in our web user interface for managing configurations, messages, and user authorizations. And best of all, the meshIQ REST API performs all of these functions using the same role-based access control and object-level security features that apply to our web user interface. Your business services are supported by application stacks that are only as solid as your weakest link. And that weakest link can change at any moment. Well, meshIQ provides real-time observability in application context so that the right people in your organization get timely alerts about issues that are happening in the mesh. Also, meshIQ provides proactive alerts that are based on machine learning. Now, this means that you can get early warnings about impending issues before business processes are impacted. Let's take a look at how this works. The control plane collects data points from various sources within the mesh to create a catalog of live runtime metrics and events. And using a graphical editor, you select data points from this catalog to create monitoring policies. Now, each policy is just a simple set of rules that are used to define the conditions for alerting based on observability. There's no scripting or programming required. And based on these conditions, the control plane can produce alerts. You can also use wildcards and regular expressions to apply monitoring logic to multiple objects within a single rule. And you can also make use of derived metrics that are based on analytics. With each sampling of data, the meshIQ control plane is running continual statistical analytics. And this enables us to detect trends and patterns in the data, which we can use to identify situations of interest that are hiding within the data, situations that we wouldn't normally notice. By detecting patterns and trends in data, the meshIQ solution provides an early warning system to detect degraded performance, unusual activities, and anomalies. Now, these analytics, they range from the simplest to the most sophisticated. Things like average value, standard deviation, historical rate of change, and many others. These analytics are used for creating dynamic baselines in monitoring scenarios. The benefit of this is that it makes it very easy to create powerful monitoring scenarios with very little effort. Now, these monitoring policies provide notifications and alerts about the severity of detected situations using a familiar traffic light pattern, green, yellow, red. The meshIQ solution includes pre-built, out-of-the-box monitoring policies that are designed to handle the most common situations. But you can modify and extend these pre-built policies, or you can build your own. Now, more and more organizations are looking for ways to make their systems self-healing. So instead of just getting a notification or an alert about a problem, they want solutions that can perform actions to fix problems when they're detected, or repair configuration drift, or launch other remedial actions. Well, the meshIQ solution not only provides alerts when things go wrong, it can also perform actions to repair issues when they arise, or to automate regularly occurring administrative tasks. For example, you can use automated actions to clean up non-compliant attributes, or offload messages from application backup queues, or migrate middleware objects between environments. These automated actions can call external programs or utilities or APIs to fix problems as soon as they're detected. Many organizations have high-profile business workflows that are subjected to some very demanding service level and audit requirements. They have to keep a constant account of indicators of things like transaction throughput, request latency, number of incomplete transactions, and lots of other metrics. Some business processes are expected to complete in minutes or even seconds, and most organizations are keenly aware that every component of a business workflow, every application, each piece of middleware can have an impact on service performance. Well, some organizations have service level commitments for business workflows that are expressed as a range of the best possible and least acceptable execution times. For all of these reasons and more, organizations today are looking for better observability of what's happening within their mesh. The meshIQ solution provides analytics of time series data to help organizations like yours to improve management and governance. And the objective is to give users better observability of the mesh on a single pane of glass in a way that's intuitive, that's easy to understand, so that people can get a better understanding of what was happening during a selected time interval, like the last 45 minutes or the last 5 days, or between 2 timestamps. Now, the benefit of this is that the user doesn't have to figure out what happened during a given time period using various logs or monitoring tools, since the needed analytics are all in one place. To make dashboards with visualizations like these, the meshIQ solution provides an easy-to-use query language for analyzing time series data. And there's also a convenient query editor that enables you to create these graphical views by filling in a form so that you don't have to learn this query language. Now, these dashboards are used to analyze behavior, relationships, and patterns in time series data, and enables users to get answers to their questions in a way that's readily understood. Also, this year, we're introducing bidirectional integration with Prometheus and Grafana, so that you can leverage the meshIQ platform with your favorite open source tools for analytics and visualization. Time series analytics can help you to identify hidden problems that you wouldn't normally see using conventional monitoring tools. It can give us insights into gradually evolving situations that often go undetected. For example, things like decreased message throughput or increased consumption of memory. These can be really difficult things to spot, especially if they occur in small increments over a period of several hours. In situations like these, there's no sudden spike that's observed in the collected metrics because they're very slowly gaining or losing momentum. One of the many useful graphical views that are provided is a timeline of performance events, like a stack chart where each column shows us the frequency and the severity of performance events that were recorded over a selected time period. Now, the analysis of issues like these is very important because we want to know how often we encounter certain types of issues and if they reoccur. Sometimes we may think that we've identified a root cause of a problem, whereas in fact, we've only fixed a symptom. Event timelines and summarizations can help us to see the big picture and answer questions like, how many warnings or errors have we seen this week? Which nodes within our cluster have had the most frequent performance events? Many organizations find it challenging to find out why business workflows sometimes deliver inconsistent performance. Often, organizations turn to application performance management tooling, APM software, to get help. Others try log analysis techniques. But without visibility of what's going on inside the mesh, these organizations have a blind side that prevents them from seeing the full story. To get real insight into message flow performance issues, you need message flow tracing and profiling with deep awareness of the actions and events that are happening within the mesh. Message flow tracing can help you to identify specific problem areas in your business workflows, things like bottlenecks in message processing and event streaming. It can also help you to locate missing messages. Sometimes it's suspected that the business data that's contained in messages like orders or contracts may be missing. And this can happen in issues where workflow processing is incomplete or impacted by an unexpected sequence of events. Now, message profiling provides additional insights. For example, by parsing message content, it can extract details like invoice numbers or regional office codes for product divisions. And it can summarize that data like counts of messages or even sums of money. Message profiling can actually show you which parts of your business are performing well and which parts require your attention. Organizations use various messaging and event streaming technologies to implement application integration. But any business workflow can sometimes deliver inconsistent performance. Well, meshIQ keeps track of the elapsed time of each message flow as well as the event counts and the timings of each event within a workflow. And it provides graphical charts that you can visualize workflow performance over time. Now, business workflows like these are often tied to service level agreements. For example, most organizations expect business workflows to complete within a certain time limit, which can even be measured in milliseconds. meshIQ keeps track of the workflows that are meeting those SLA criteria and those that are not. Conventional application monitoring tools just don't provide full visibility of what's going on inside the mesh. So to illustrate that point, let's take a close look at this display. What is this picture really telling us? So let's start at the top and then work our way down to the bottom. Summarized data is displayed at the top. We see the total number of message flows that were executed within a selected timeline. We see the number of message flows that met or failed SLA criteria. From that summary view, we can access the details of all message flows or any specific flow with just 1 or 2 mouse clicks. Messaging events for a selected flow are shown in the middle of the screen. Each line shows us one event with the name of the application, the name of the middleware object, the timings of each event, and the message details that were captured at the time of execution. At the bottom of the display, we see a message flow topology. The graphic gives us a picture of a selected message flow with the relevant application names and object names for each event. The meshIQ solution captures live messaging events at runtime from within the mesh. It streams those captured messaging events to the meshIQ data repository where they're indexed and correlated for analysis and search. And finally, the meshIQ web interface enables users to view useful information about message flows through a variety of visualizations. In order to provide insightful analytics from the captured data, the meshIQ solution enables you to set up service-level objectives for message flows. For example, you can specify objectives for the elapsed time of workflows or completion codes, or objectives that are based on data parsed from within the message. You can also perform root cause analysis. For example, the solution uses machine learning to determine normal behavior of message flows belonging to a same set, and it can identify outliers. And also, the meshIQ solution provides alerting in situations where those service level objectives are not met. So that concludes our presentation. Thank you very much for listening, and I think we'll do a Q&A session now.
Okay, so I got a bunch of questions that came directly to me. So if you guys do have questions, please put them into the chat. We'll read the ones that I got directed to me and the ones that are in the chat as well. But I did get a lot. They were flooded. So if you have anything else, please put it into the chat. So the first question is, how is scalability achieved with the solution using Kubernetes?
Right, so scalability. Well, as part of the microservices architecture of the meshIQ solution, we talked about the control plane. Now, the control plane, it includes a central component that we call a CEP engine or CEP engine. That stands for complex event processor, by the way. So this CEP engine manages the configuration and performance of multiple messaging and event streaming technologies across an enterprise network. So this CEP engine component, it manifests itself as a container. So in the Kubernetes environment, it's what we would call an instance of a pod, or a pod instance, right? So depending on the number of endpoints to be managed or the size of your environment, you'll have one or several of these containers at runtime. So if your messaging and event streaming environment increases in size or complexity, what you do is you add more of these containers to cover that scope.
Okay. Is Kubernetes required for running this product?
No, actually. Kubernetes is really a deployment option. It's not a requirement. The meshIQ solution can be deployed on Kubernetes or on containers without an orchestration platform. It can also be deployed on virtual machines, on cloud compute platforms like Amazon's EC2, or even on bare metal servers.
Okay. You showed a number of Kafka examples in this presentation. Is this product principally built for Kafka? Also, that's a two-part question. Also, what distributions of Kafka are covered by this product?
Okay. True, there were a certain number of Kafka examples that were shown, but it's important to keep in mind that meshIQ is an observability platform for multiple messaging, event processing, and streaming technologies. So it's designed for managing and monitoring a complex mesh landscape. It's designed to address the needs of administrators, application owners, architects, developers, any group of persons or teams that need to work with one or more messaging, event processing, and streaming technologies. So it's not specific to Kafka or to GoEMS or IBM MQ or any other specific messaging or event streaming platform. It's actually designed for all of them. Now, with regard to Kafka, since the question's raised, we do cover all distributions, including open source Apache Kafka, the Confluent platform, Confluent Cloud, Amazon MSK, IBM Event Streams, Red Hat MQ Streams. I could name others, but I think you get the picture. All distributions of Kafka are actually followed with our product.
Okay, so can this product be used to manage messaging and event streaming resources that are deployed outside of a Kubernetes cluster, as well as those that are deployed inside the cluster?
Yeah, outside as well as inside, sure. Yeah, you can do that. I mean, the meshIQ data plane, right, is connected to messaging and event streaming endpoints that are deployed, you know, either within a Kubernetes cluster or actually anywhere within an enterprise network. Now, with regard to Kubernetes, there are networking prerequisites for incoming and outgoing traffic on the cluster. So for those considerations, it's probably best to consult with your Kubernetes administrator. You can define connections to endpoints using the meshIQ web-based user interface, and also by using our REST API, by the way. When you define a connection, the details that you provide are dependent on the endpoint. So for example, you provide things like an IP address, port number, security information like user and password, or in some cases, additional information, like if, for example, if SSL is required.
Okay, this one is also seems like a two-part question. Does this solution require installation of any software on the managed broker or queue managers? And are any changes required to the managed resources?
No, emphatically no. meshIQ doesn't require any installation of any software on the managed endpoints. There's no changes required to your messaging servers, your queue managers, your clusters, your brokers, nothing like that. The meshIQ data plane, it manages the communication with middleware servers using existing communication paths. So for example, for Apache Kafka, the data plane connects to, let's say, the Bootstrap server of a Kafka cluster, and it issues management commands and receives replies. For things like IBM MQ, for example, the data plane sends remote requests via channels like server con channels to connect and issue management commands and receive the replies from the queue managers.
Okay. How would you compare the meshIQ product to the tooling that is supplied by other software vendors for managing messaging and event streaming technologies?
How would I compare? Well, I mean, there's a lot of use cases where meshIQ delivers significant added value in comparison with some of the other management tools that are available for either for management or monitoring or analytics or all the above, really. I mean, this is a platform. This is a solution platform that provides governance. It covers things like configuration and message management and secure self-service. It has role-based access control, intelligence with real-time monitoring, proactive alerting, trend pattern detection, built-in analytics. It covers actions. It triggers automated actions that are based on events, and does introspection. So performance analytics that are based on historical data, as well as tracking and tracing of application message flows. So in substance, the solution is designed to give you enhanced observability with a single point of control for multiple messaging and event streaming technologies. It's also about saving time, doing things more efficiently, reducing your workload.
Okay, and this one seems to be the last one. How much time is required to deploy this product and become efficient in using it?
Well, the solution only takes a few minutes to install on Kubernetes, on containers, on VMs, or even on bare metal. It only takes minutes to configure connections to your messaging and event streaming servers through our data plane. We have a customer resource center website that provides tutorials and videos that show you how to use the product, and full documentation set is available on that site as well. We offer professional services to assist our customers, and we provide training. The timeline for a full-scale deployment is really variable. It depends on the size of your environment and also your objectives, above all your objectives. It can be as short as a week, or it can take, potentially several months. So, like, for example, we deployed our solution recently on a worldwide scale to a major bank with thousands of messaging servers and over 6,000 users. And we accomplished that in less than 9 months.
Okay, so that seems to be the last of the questions. Does anybody have any other questions? Okay, it doesn't seem like that. So I I guess we're going to end this. I want to thank everybody for attending today. So the on-demand version of this webinar will be posted on the meshIQ website at www.meshiq.com later today or sometime this week. Also, please note that this webinar is a part of a series of tech talks. So the next one is going to be scheduled for April 18th at 11 a.m. Eastern Time. And the topic for that will be why observability is so important for the modern integration mesh. And this is going to be a collab tech talk, almost like a podcast, if you will. So it's going to be very exciting with our CTO, Albert Mavashev, and Jason Bloomberg at Intelix. So stay tuned for that. Look for those invites, and we'll be excited to see you guys there. Thank you so much. Thank you, Scott. Thank you, everybody, for attending, and have a great day.